Kotlin to create libraries that you can use then on Android and iOS. Okay? Not user interfaces, just libraries. Okay? So your business logic, it can be your models, your view models. You can build that in Kotlin and then use that in a normal Kotlin Android project or in a Swift project on iOS. Okay? That's known as Kotlin multi-platform mobile. We are close to see some code, but before doing that, let me show you this diagram really quickly. So this is the current Android app development ecosystem. You have Kotlin Java code that can use Android Jetpack libraries, and those libraries can actually talk to your Android SDK. So we are going to write Kotlin code, right? So our Kotlin code can use Jetpack and also can use directly the APIs from the SDK. Also, you can write your own C++ code and connect them through something known as Java native interface. It doesn't matter. So this is the ecosystem. Okay, what we're going to write is just Kotlin and maybe C++. Not today, okay? But on another project, you can also write C++. Today, we're going to just write Kotlin. The rest is just part of the build or part of the operating system. It's not our code, okay? And our code will be just Kotlin today from that ecosystem. But just have in mind that code can talk to C++, they can talk to Jetpack libraries, and also they can talk to the Android SDK APIs. So I don't know, if you want to use Bluetooth API, well, that's part of the Android SDK. You can talk to that API. And in the APK file, so when you're building the app, it will go Dex code. Dex is Dalvik executable. Oops. So Dex is Dalvik executable. And also Jetpack, because Jetpack is not part of the operating system. Jetpack is a library that we are deciding to use. Okay, it's from the Android team, so it's kind of an official library, but it's still a library. So that means that in your APK, the compiled code of Jetpack will also be shipped in the package. And if you have C++ code, you will have the libraries compiled. So we have a question on installing Android Studio and problems with one of the utilities that's called Haxum. So that's actually an emulator, let's say, improver. So it's a tool that will improve performance of your emulator on Intel processors. If you have problems installing, you need to read like the message that you have. Typically has to do, your computer is not Intel compatible for VM acceleration. And sometimes you need to get into the BIOS of your computer and enable virtualization. So if that tool is not working, it shouldn't be a big deal. The only problem is that your emulator will work slower, okay? Because it's not actually running directly into your CPU. The emulator is a VM, so it will convert ARM to Intel, and it's actually slower. It's time to write some Kotlin code. So in the repository, there is a public folder, and in that folder, we have assets. Okay, it's a zip file. If you unzip the file, you will get some PNG that we will use in a couple of minutes, and also you will get into a Kotlin 101 folder. What we're going to do now is to open Android Studio into that folder. It's not actually an Android project. This is actually a couple of files with the extension KTS. By the way, Kotlin files are KT files. KTS, what's that? The S is from Scratch. A Kotlin Scratch file. What's a Scratch file? It's actually a file to play with Kotlin without actually making an app. Okay, that's kind of the idea. You can open that, by the way, if you want in VS Code or any other IDE that you want. In this example only. For Android development, we will actually need Android Studio. But for these files, you can open this in Android Studio if you want, just to see and play with Kotlin. In Android Studio, you can open, and then you go directly into the folder. In this case, I have it into Assets, Android, Kotlin 101. It will look like this. So you have a list of files, and then with the tip of the day that I don't want, and then the code on the other side. So here we're going to just see some code, and also if you want, you can run Kotlin code. That is like a playground. It's a place to play with Kotlin without actually making an app. Okay. So basic expressions. Kotlin code looks like JavaScript or any modern language when you first see it. So if I throw you some Kotlin code, you will understand most of it without even doing any explanation. So I will just jump directly into the differences and really quickly over the things that are usual or similar to other languages. So Kotlin looks like any other language. For example, semicolons. Semicolons are there, but they are optional. And I can say that 99% of the time, you're not going to use semicolons. You use semicolons only when you have two expressions, two sentences in the same line. And that's not something you want to do, actually. Okay? So you create variables, as you can see really quickly, with var. So that's actually pretty straightforward, as with JavaScript. We will get into data types and all that stuff in a minute. Boolean conditions, they need parentheses. So for example, if you're coming from other languages, Python, Ruby, Swift, here have in mind that this is like JavaScript or C or other C-based or C syntax languages. You need parentheses on if, on whiles, on fors. Print and print line. Print will send a message to the console. Print line will send a message and create a new line. One big important thing here, when we are using print to talk to the console is not the phone. Okay, the console is an invisible part of your app, of the operating system. And Android does not support printing without a new line. So actually, when you do print, it goes to a buffer until you do at least one print line. When you do the last print line, you will see that on the screen, meaning that if you are sending print messages, you are not going to see those messages in the console until you send a new line character or a print line. Okay, have that in mind. When you're doing console Kotlin applications, you can use print and it works. Okay, but on Android, we are running on a different operating system with its own rules. So in terms of style guidelines, variable, function, and package names are using camel case. What's a package? Similar to Java package or similar to namespaces in .NET or PHP. It's a way to group code under a name. Okay, all of them are using camel case. So we start with lowercase and then we go uppercase. You know the deal. Constant names. Okay, they're using upper snake case. That is, for example, this one, max length. We will talk about this in a minute, like const pal, what is that? No worry for that. And data types, they use title case, as in JavaScript, Java, and many other things, like a class, an object that we don't know what that is yet, but let's say that it's a type, interfaces, also objects that are representing singletons, we tend to use also title case, so we start with uppercase. These are just guidelines. Of course, no one is going to enforce you these ideas, okay? Just guidelines. Something interesting is that conditionals are expressions. So you can call a function and put an if inside the function. Okay? And this is different to other languages. Probably you are used to, like, I don't know, less than 2. Else more or equals to 2. Something like that. This is perfectly valid in Kotlin. So this is actually replacing the ternary operator that probably you are used to. The ternary operator is not available here. You need to use if instead. It's just that. It's just the ternary operator with a different syntax. Okay, makes sense? We don't have a switch, but we do have a when that it's acting like the switch. Okay, and it's even more powerful. We use when and then different cases. On each case, we use this one known as the thin arrow, dash and greater than. And we can have one line, we can have a code block, and there is no need for a break. Okay, there is an automatic break here going on. We can also use ranges, multiple values, and even we can use operators. For example, in this case, asking about the data type of something. Else, it's what we are used to as default on other languages. Okay, it's just that, and you get used to that. It's not a big deal. Loops.
And it goes through all of them, right? So it can go through multiple cases, right?
Good question. So what if you want to go with multiple cases? By default, it's not going through multiple cases, okay? Because they realized when they created Kotlin, the language, that most of the time we are using the switch, or in this case the one, for exclusive options. But if you want, you can request a fall through. So it's the other way around. Instead of breaking, you are going to say that you want to continue on the next one. Okay, and in that case, you use fall through. So you can request explicitly that you want to move to the next case. Okay. Loops, we have the standard while, so it's just a while, as you know. Okay, don't do this at home, but while true. And the for, we only have for in as an option. If you want to use the old for I equals 0, I less than I plus plus, you can use ranges like this. A range is like some kind of a literal collection on the fly. Okay, it's not exactly a collection, but it seems like that here. Okay, so in this case, 0 to 10 without 10. Okay, so this will print 10, 0 to 10, to 9. Sorry, 0 to 9. Okay, simple. So that's simple. Variables and types. So now I'm opening this lesson 2 that we have here. Okay, remember, KTS is just this simple way that we have to see some Kotlin code. We can execute this code, but without attaching this to an actual app. Okay, that's kind of the idea. This is not an app. We are not building an app. We are just playing with Kotlin, and for that we use this KTS file format that we'll never see again. We will never see this format again later. Okay, all the files will be just KT. That's the extension for Kotlin. So we mentioned that it's an statically typed language. So actually every variable will have a type. So in this case, data will have a type even if I don't see explicitly any type. If you hover with your cursor, you will see there that it says integer is really small. Okay, but let me see if I can zoom in a little bit, like so. So you can see it says that data is an int. So it's actually using, it's actually inferring the type based on the value that I'm setting. But if I want to, I can use colon and the type, such as int, capital I, because it's a data type. Okay, so be careful if you're coming from other languages where int is with lowercase I. So this is a mutable variable. We use var for a variable. Okay, but we also have immutable variables with the keyword val from value, val, not var. By the way, do you know the difference between an immutable variable and a constant? Does anyone know the difference between?
Compiler type, compiler time.
Compiling time. It has to do with that, exactly. A constant value, it's something that needs to be defined at compilation time. When you're compiling the app, the value must be set. That's a constant. An immutable variable, it's a variable, so it's actually a place in memory when you're executing the app. But the idea is that once you set a value, it's immutable, so you cannot change that. So for example, in Kotlin, we have both constant and immutable variables. Typically, we use immutable variables. Immutable variables can be set with values coming from a database, from the network, from what the user is typing. A constant, no. A constant must be set at compilation time. So a constant, it's actually const val. That's how you set that. And we don't have global constants. They must be part of a structure, such as an object or a class. We don't know what an object is. Give me a minute. Okay? So have in mind that. So if you're coming from other languages, val is like let in Swift, is like const in JavaScript. Okay? But here is val. Then types. As I mentioned before, we use colon. Okay? But if not, they are infer. Similar to other languages with type inference, we might have problems. For example, we have a price that is a double. Other price is also a double because I'm setting a value even if I'm not explicitly saying double. But sometimes we want a double, but we are getting an integer. That's because 23 is an integer. Well, we can solve the problem with .0. In that case, it's a value. It's a double. So a .0 will force a double. Also, you can force explicitly the type. In case you have this ambiguity, you can resolve those ambiguities by defining the type. A double is by default a double precision float. We also have the type float, and there is an f that we can add here to explicitly say that we don't want a double, we want a lower precision float. Okay, we don't going to use this a lot actually. Okay, but have in mind it's there. We have a structural equality, that's double equals, and triple equals is referential equality. So the first one is actually like executing the equals method of that object to see if the contents are equal. For example, two strings will give me true, but will give me false on referential equality because I'm actually making two objects. Okay, so this is true because they have the same value, and this is false because they're different objects. Every time you create a literal string, it's actually a different object in memory. Okay, similar to what you have on other languages. It's similar to JavaScript. It's not the same, but similar to the idea in JavaScript. Core data types, strings, characters is char, int, double, boolean, and we have any. We don't typically use any a lot, but any means, well, in this variable, I can hold any kind of object. And then you need to cast or ask for a type before actually using it. Okay. As I mentioned, we have float. Also for integers, we have bytes, shorts, and longs. So integer is actually goes between short and long in terms of how many bits it's using. We use double quotes for strings. Okay. We also have a way to create a multi-line string using triple double quotes. Okay, and this is multi-line, and the multi-line will let you. It's actually pretty good, for example, for JSON, because now you don't need to escape the quotes. Okay, so something like that. On every string, we have template expressions. Template expressions are using the $sign when it's just the name of a variable, or we use the $sign and a code block for a more complex expression, and it's going to make a replacement automatically on that string. So that's pretty straightforward and easy to use, similar to JavaScript in that case. Collections. So Kotlin includes several collections ready to use, as we expect from a modern language. So we're not going to cover all of them. So let's cover quickly the ones that we will use during the rest of the day. We have lists. A list is what we typically know as an array. Okay, but here we have the type list. We define the type with angle brackets. Okay, this is actually a generic, in case you know what a generic is. So we define an array of countries or a list of strings. And unfortunately, if you're used to JSON, we don't use that syntax for literals. We use a constructor that has the name list of. So list of, it's actually like in JavaScript, opening square brackets and setting the countries. Okay, like this. But here we use list of. It's a constructor, it's a global constructor that returns a list of the objects that you have. Okay, by default, a list is immutable. So after I set the list, I cannot remove or add elements to it unless I create a mutable list. That is another type. So the mutable list has all the methods to add, replace, or remove elements. So you pick when you make a list if you want it mutable or unmutable. Okay, we also have sets. Okay, as I said, the difference is that it cannot contain duplicates. So in this case, strings will have 3 elements because C is going to be stored once only, and there is no order in a set. We have a map that is kind of a dictionary, like when you have a key and value. And we also have arrays. And you say, we call it list. Well, actually, this is for Java. Sometimes, I mean, this is actually probably low level. We are not going to use it today, but I'm just going to mention that quickly or briefly. We mentioned that the SDK is written in Java. So from Kotlin, when you are talking to the Android SDK, sometimes you need to make some conversions. It's not a big deal, but for example, it happens on lists. So there is a quick way to convert a list into an array. That it's a similar structure, but it's not exactly the same. So that's why we need to convert that into arrays when we are working with the SDK. Again, not for today. We will stay within Kotlin today, and it will work. Any question on collections?
Did you say one of these can't have duplicates?
The set.
The set.
The set cannot have duplicates. Remember the idea of Venn diagrams from college? That's a set. So you cannot have 2 of the same kind, and there is no order. That happens with sets on different languages. Okay, so something that is probably new to some of you: null safety. Null safety. So in Kotlin, when you express, let me put this for a minute so I don't spoil what's happening. When you have a variable like this and you say that my name is a string, it must contain a string. It cannot accept null, like in Java or JavaScript or other languages. So if it's a string, it must be a string. If not, it's not compiling. I need a value. But sometimes you know that sometimes, hey, I don't have a value, or maybe I accept nulls. Well, in that case, if you accept a name with nulls, you use a string question mark. Question mark says that the type that we have before that character, it's actually optional. So it accepts nulls. Okay? So that means that now we can assign a null, or by default it will have that value. So the problem with this, so it sounds okay, simple to understand. So here I have an example with my last name that it handles a null value, is operators, because actually if you want to get the length of the string, it's not working. Like so. Because if you do this, I mean in Java or in JavaScript, it works. But you may have the well-known friend null pointer exception or null reference exception in C#, for example, that it's actually pretty annoying, right? Well, Kotlin will force you to manage this situation, because now my last name can accept nulls. I need to do something because maybe there is no last name to ask for a length. So I need to operate. This is not going to work, and it's not going to compile. I need to make a decision, okay, about the null situation. So the first possible decision is to use an operator that has a weird name to remember, the not null assertion operator. It's actually double exclamation mark. Double exclamation mark. For those of you coming from Swift, there we have a similar operator with 1 exclamation mark. Here it's 2 exclamation mark. In this case, we are saying that we know, or we are, as developers, we are guaranteeing the developer that it has a value and it's not null. And this is like on Java, just asking for the length, and I don't care if it's null or not. Of course, if it's null, your app will crash. Okay, but this is a way to like bypass the compiler and saying, you know, compiler, I know you don't like this, but trust me. Okay, go ahead and try to get the length. Okay, so we try to avoid the usage of this operator as much as possible. We use this with control exceptions. Okay, what other operators we have? We have another one called the safe call. the safe call, it's actually like this. It's using question mark dot. So in this case, the safe call will actually call length only if it's not null. And if it's null, it's going to return null to the color of the expression. So actually the type of length, if I zoom in a little bit so you can see the type, it's int question mark. So the length can be an integer or null, because if the last name is null, I don't have a length. Okay, so that's the safe call, similar to other languages. It's the same syntax. And finally, we have an operator for default values. So for example, if we use a safe operator, but I actually want an integer. I want an integer. I don't want an optional integer. I can set the default value. And we set the default value with question mark, colon. Question mark, colon. Okay? So, and then the value from 0. So if this expression is null, it will use 0, the default value. Okay? Does it make sense? This is like in Swift or in JavaScript. Now we have this operator, the double question mark. Well, here it's question mark colon. And I have a question for you. Can you guess the name of this operator? You know it because you are laughing. So you know the answer. This operator has a name in Kotlin. What's the name?
I had to look at the picture to figure this out, but it's the Elvis operator.
The Elvis operator. Why it's called the Elvis operator? I'm talking about that one, okay? Because if you turn your head anti-clockwise, it should be 90 degrees. It seems for someone that it looks like the Elvis hair, okay? Fortunately, it's not called the Donald Trump operator, right? Because it can be applied as well. We are talking about politics. I'm talking about hair here. So it's called the Elvis operator because it looks like Elvis Presley hair, okay? Curly hair. I don't know. Anyway, a funny fact about Kotlin. Okay, now you will see the hair when you look at that operator. I promise you, because I'm seeing the hair every time I'm seeing it. Okay, so those are the null safety operators available in Kotlin. Okay, functions and lambdas. So a function is similar to the functions that you're used to, with some tweaks on the syntax. For example, instead of using the function keyword, it's the fun keyword. Some people say fun. It's up to you, but let's say fun. Fun is funnier, I guess. So fun, the name of the function, and parentheses, as you're used to, and a code block. If the function returns a value, we must say so by using colon and the data type that we are returning. Okay? By default, we're not returning. So if you add a return, it's not going to work. It's not going to compile, because the signature of the function doesn't say that it's returning something. Okay? So we must add colon. Sometimes you add a space here. In that case, you can pick the one you prefer. Something interesting that we have is that if the function has only one line, I can get rid of the return first. Okay? But also, I can get rid of the code block. And instead of a code block, I can use equals. So in that case, it's a one-line function declaration. And there is an implicit return. The equals, it's kind of an implicit return. So calling a function returning to is equals to that string. That's the idea. Okay? It's not mandatory. It's something that you can pick to use. Arguments. Arguments are actually pretty straightforward with the differences in syntax that we have in Kotlin. So we use the name of the argument, colon,